Welcome back to ChemExam Explained, where the aim is chemistry clarity exam mastery. In this video, we will be looking at Cape Chemistry, Paper 2, Unit 2, Module 3, 2025. Let's go. 3 Part A. List 4 factors that must be considered with respect to the location of an industrial plant. The availability of raw material, the access to water supply, transportation links, skilled labor, cheap energy sources, environmental impact, and finally, space for expansion. Any two. 3b, Part 1. Sulfuric acid is one of the world's most important industrial chemicals. With the aid of equations, outline the first two steps in the contact process. Well, the first step is the oxidation of sulfur to form sulfur dioxide. And you must put in all your state symbols. So this should be gas. And step 2 now is SO2 that was produced earlier will be further oxidized to produce SO3, which is sulfur trioxide, using vanadium 5 oxide or vanadium pentoxide catalyst. Your arrow must be the reversible arrow. B, Part 2. Give an example of the use of an oxide of sulfur in the food industry. So the first thing we want to know is that sulfur dioxide is a reducing agent and the food spoils because of the oxidation process. So the reducing agent would now slow the oxidation process. So the sulfur dioxide is acting as a preservative, and in this case, preservative of dried fruits, but it can be used as a preservative in wine and many other things. B, Part 3. State 2 environmental concerns associated with sulfur dioxide. Well, we know that when sulfur dioxide dissolves in water, it forms sulfurous acid. And of course, that will cause acid rain. The SO2 gas itself will cause respiratory irritation as it is a choking gas. 3, Part C. Bauxite ore is a mixture of aluminium oxide and other oxides. With the aid of balanced equations, briefly explain how aluminium oxide is separated from bauxite ore. Well, the first thing we want to do is to crush the bauxite and add sodium hydroxide. Now, the reason for adding sodium hydroxide is so that the impurities can be removed. Now, aluminium oxide that is in the ore will react with sodium hydroxide to form the salt sodium tetrahydroxyaluminate. And of course, this is now in the dissolved state. Now, the impurities like your iron oxides, your titanium dioxide, those will remain insoluble and can be filtered off because they are not amphoteric and will not react with sodium hydroxide. The silicon dioxide, it is slightly acidic, therefore will react with the sodium hydroxide. However, it will form silicates, which is a precipitate, and that now can be precipitated off with the other impurities, leaving your aluminum oxide in solution. So after we filter off the impurities, we are then going to precipitate out the aluminum hydroxide out of the salt or our aqueous solution that was present before. In order to precipitate that, you are going to add previously made aluminum hydroxide solids, and that will cause aluminum hydroxide to be formed, which is a precipitate, along with your sodium hydroxide. After that, to get our pure alumina, which is our aluminum oxide, we are then going to heat the aluminum hydroxide. And when you heat hydroxides, you produce the metal oxide and steam. And that is how we produce our pure alumina or aluminum oxide from the bauxite ore. C, Part 2. Aluminum oxide is electrolyzed to obtain aluminum, and the process is called smelting. Write the main reactions occurring at the anode and the cathode. Well, at the anode, we know that the oxide ion would move to the positive electrode where oxidation will take place. So that is where now you lose electrons. And so oxide ion will produce oxygen plus 4 electrons, and you'll observe effervescence at the anode. At the cathode, the metal aluminium ion will be reduced to form the aluminium metal in the liquid state. So at the cathode, the aluminium ion would be reduced by gaining 3 electrons to form the metal aluminium in the liquid state. Part 3. Describe any one impact of the production of alumina on the environment. Well, red mud disposal, which leads to soil and water pollution, because the red mud, which is the impurities, if it seeps into the water supply, it is going to contaminate the water supply. And of course, it will affect the pH of the soil. It also causes land degradation because in order to get the bauxite, you have to first deface the land. And removing the hillside is unsightly. Part D. Oxides of nitrogen are collectively called NOx, which is nitrous oxides, and are produced when fossil fuels are burnt in air in combustion engines. Write the equations that show the formation of these oxides. So the first one is N2 plus O2 produces NO, and you balance the equation, and they're all gases. And then the NO will be oxidized further to NO2. Again, balance the equation along with the state symbols, and they are all gases. Part E. Nitrates and phosphates are common pollutants in water. The cadmium reduction method is a suitable method used in the determination of nitrates in industrial laboratories. E Part 1. Describe a qualitative chemical test that can be used in school laboratories to detect the presence of aqueous nitrate ions. And so we can look at the brown ring test, where you add iron sulfates along with concentrated sulfuric acid, and it forms a brown ring between the two solutions. Another test you could use is concentrated sulfuric acid followed by copper metal. And what you'll produce there is a blue solution of copper 2 nitrate and NO2 gas, a red-brown gas, which is acidic. Finally, you could use your zinc and aluminum powder. You can add that after adding sodium hydroxide. So it is sodium hydroxide followed by the addition of zinc powder or aluminum powder. And what will happen there is that you will produce a pungent odor, and that pungent odor is ammonia, which you can use red litmus paper now, or red and blue litmus paper to test for it. So the red litmus paper should turn to blue, proving the presence of ammonia gas, while the blue litmus paper should remain the same. E Part 2. Compared to the cadmium reduction method, state with reason whether the method suggested in E Part 1 is suitable for the determination of nitrate ions as a pollutant in the water supply. And so we are saying that no, it is not suitable for the determination of nitrate ions. I mean, it is suitable to identify that nitrate ions are present, but not to determine the amount of nitrate ions present, because the cadmium reduction method is used to reduce a nitrate to nitrite, and then you form a colored compounds which can be used in the spectrophotometer to quantitatively tell the amount of nitrate ion present. But with the iron 2 sulfate and the sulfuric acid, or the sodium hydroxide, followed by the zinc or aluminum powder, these are just methods used by schools to identify that nitrate ions are present. So it is a qualitative method. It has low reliability and low sensitivity. So therefore, it is only suitable for identifying the presence of nitrates, which is done in school laboratory. So suitable in school labs for identifying the presence of nitrates. So again, to answer the question, yes, it is suitable to identify that nitrates are present, But in order to determine the amount of nitrate present, it is not suitable because the cadmium reduction method is a quantitative method that tells you the amount of nitrate present in the water, while the other methods we use in the school labs is just to tell us that nitrate ions are present. E part 3. Name the reagent that can be used in school laboratories to detect the presence of phosphate ions. And so the main reagent is ammonium malabdate. This ends question 3, module 3 for Unit 2 Chemistry 2025. Thank you.